All right, we're going to talk about the periodic table, and I thank Mr. Larry Scheffler for putting his PowerPoints online. I'm going to borrow from them. I edited them, but he had some good stuff. So here we go. Oh, look at the periodic table. Again, hopefully you remember from before that they are divided into groups. Most of the periodic table are metals. Okay. You have the nonmetals in the upper right. Hydrogen is also considered one, and then you have the metalloids kind of spanning the gap between the two. Metalloids having properties of both metals and nonmetals. Metals being shiny, easily lose electrons, conduct heat and electricity. Nonmetals tend to gain electrons to bond. They are brittle when solid, and they tend not to conduct heat or electricity. All right, so hopefully at the end of this screencast we will be able to describe the arrangement of the elements in order of increasing atomic number, distinguish between group and period. Periods go this way, groups go this way. There are 18 groups, and the periodic table. Apply the relationship between the electron arrangement of the elements and their position in the periodic table only up to element 20. I actually expect you to be able to go farther. And then apply the relationship between the number of the electrons and the highest occupied energy level and its position on the periodic table. Most of this should be a review. The S block, the P block. Helium, remember, is the 1s2, but it's put here because it's a noble gas. You have the D block in the middle, and then you have the F block being the actinides and the lanthanides. Okay, I should have said lanthanides and actinides because these come first. Okay. Cool. There you go, the periodic table. It is important that you know specific groups. The first group, group 1, are known as the alkali metals. I would actually exclude hydrogen from that. Okay, so the alkali metals are from lithium to francium. The second group are your alkaline earth metals. You have your halogens, or group 17, 7 in the IB. Then you have your transition metals. We'll find that scandium and zinc are really not considered transition metals, but they do sit in that block. We have the lanthanides and the actinides, and then we have the noble gases. Metals, the majority of the periodic tables is metals. Most of the metals are solids, with the exception of mercury being a liquid at room temperature. You have the nonmetals on the right-hand side and the metalloids in between. Representative groups, those are also known as the main group elements. Those are the S and the P group. Those are the ones that we study most often because they follow the rules. Transition, again, are in the center. And then the rare earth are the lanthanides and the actinides. And rare, they are rare. I think you guys know all this. With the electron configurations, hopefully you remember that all group 1s end in an S1. They all have one valence electron. All of the group 2 end in an S2. They have 2 valence electrons. Group 3 end in an S2P1, 3 valence electrons, and so on till we get to the 2P6, with helium again being that exception because it's a 1s2. The period that these elements are in is the highest occupied energy level, coincides with the period number. Remember the D, the energy level that this D sublevel is in is 1 less than the period it's in. And if I were to put the lanthanides and the actinides in here, the Fs are 2 less than the period number that they are in. Groups or families go up and down. Periods go across. Elements in a group have similar electron configurations. Horizontal rows known as periods, up and down known as groups. And these physical properties change, I guess chemical as well, change from more metallic behavior to a non-metallic behavior as we go across a period.